Welcome back to the Gruber Morning Show. I'm Pete Gruber.
I'm Mark Schaffner. Good morning and welcome.
We appreciate you guys joining us. The picture behind us, for those of you that are able to see our green screen rendering, is again artificial intelligence. The prompt that I asked for was, you know what? Let's get a new studio on Mars. And that's what it came up with. You can see out the windows there, it does kind of look like a Martian landscape or Sedona or Monument Valley. A
Yeah, it
combination
could
of the
be
two.
pretty close. The pink sky or orange sky, there's not enough of it there. That could be an Arizona sunset as well.
Yeah, very cool. So it looks like we're going to bring up Instagram here shortly. Jesse, you're going to see the back of his head here. And
Now I wanted to start out. I misspoke a few minutes ago in our pre-show. We were talking about whether or not we had any questions from Thursday. We do.
yes.
There's a question that I did some research on, and the question was from Dustin Goffran. He says, "Do you know the impacts of DC charging on LFP batteries?" And we did not know at the time if we had significant impacts of DC charging. So we said, we're going to go ahead and take some time here, and I'll take and do a little bit of research on this. I took a look and found that the LFP battery technology, or the LFP battery chemistry, was very similar to and the results of that LFP chemistry were very similar to the recommendations that Tesla has, where it's okay to charge to 100%. The lithium iron phosphate battery technology, or the chemistry, is designed to be able to charge up to 100% on a regular basis. And that technology also is less susceptible to battery degradation from high voltage DC charging, just like it's less susceptible to battery degradation from being charged up to 100%.
Okay. All right. Well, thank you. You know what? It just occurred to me. Our audience is somewhat familiar with the rest of our social media team here in the studio, and Richard is not with us today, and there's a very good reason for that.
Yes, absolutely.
He is a father now, and yesterday his daughter was born, and he is now on paternity leave, taking care of his daughter and his wife or girlfriend. And but yeah, it was a great picture. I think Jesse showed us on his cell phone, and like all newborns, it didn't look like they were too happy going through that process. But
Well, sure.
yeah, that'll level out at this point.
So, Rick, congratulations, Richard, on being a new father for the first time, and hope that you and your significant other are completely blessed with your new daughter.
Totally. Do we have a name for this little new creature yet? No? Okay. All right. Looks like we've got some questions. Lightning Rod, how are you? YouTube coming in, one of our regular contributors and visitors. He says, hello from Thunder Bay, smoky and warm with a little breeze, or a light breeze. Okay. And then YouTube, Ray Johnson. Ray and I spoke actually before the podcast. Ray is one of the ones spearheading on Facebook a site regarding the Tesla Model S battery problems, and it's a long name, but it has BMS 029 in it. So if you're interested in looking what's going on that site, you can certainly look that up on Facebook. And Ray gives us quite a compliment. He says, greetings from Reno, Tahoe area. Great podcast. You both are budding successors to the old NPR's weekly radio show, Car Talk. And, I remember that. It was a great show. Then he mentioned some other ones. They were known as Click and Clack and the Tappet Brothers. Well, thank you. Yeah, that was an inspiring show, by the way. It was always somewhat humorous, informative, and that's exactly the goal that we have here, is to spend time in the EV space and promote the transition to sustainable energy, and bring in guests that share that passion, which, by the way, reminds me, Thursday, Farzad Misbahi will be with us, and he's definitely a mover and shaker in the EV space these days. So Thursday at 10 a.m. Pacific Standard Time this time of year. Join us.
And Ray, thank you again for the very nice compliment. He also had a question for us. Is there any update on the BMS UO29 reset attributed Model S fire that you headlined in your podcast just over a week ago on May 25th?
And yeah, I told Ray through email that I was going to check with you to see if you had dug up anything on that.
And I did attempt to dig up some information on this and did not find anything else in the press more recent than May 25th. Now, to just recap, since not everybody who's watching right now may have not watched then, back on May 25th, a Tesla Model S caught fire, and it came out during the investigation of that fire that the car had been sold to a person 2 weeks prior, had been sold as though it had a good battery. But what had happened is that the dealer had contracted with a consultant who reversed the BMS UO29 error that the battery was experiencing. Once this person who had bought the Tesla, he reached out to Jason
Hughes.
and said, "What do I need to do? I'm not sure exactly what's going on with my car." And Jason said, "Park it outside, run the air conditioning, get it down below 50% charge. Your car is in danger of catching fire." And he went out a few hours later and the car had already caught fire.
Okay. So as news develops regarding this, we'll certainly report it. And at this point, though, we're still not totally informed as to what the outcome of this event was.
Yeah, I haven't seen anything new beyond what we had reported on the 25th and did take some time to look.
Are we ready to post the picture there, Jesse? I'd like to post that picture of Elon. And, Elon is involved in a lot of things. I think, as everybody knows, from Neuralink to Boring Company to Tesla to SpaceX. I mean, it just goes on and on, even tequila and, flamethrowers, you name it. This latest one, apparently, he was working on a age-defying elixir, and he was testing it on himself, and apparently it was the dosage was a bit too strong.
So kind of a fountain of youth type of thing. That.
Can you pull your mic closer, please?
Exactly, yeah. All right, how's that? Got a close mic, and look at this. So anyway, Elon is having fun with this. He says, "Guys, I think maybe I took too much." And we can't tell if this is one of Elon's children. It certainly looks like him. Or if this is a AI rendering of Elon young. Now, you could do that as well,
Oh, yes.
That's the cool thing about AI. So that's probably what Elon looked like when he was younger.
I'm guessing that this might have been one of his children, possibly his oldest son, because if you look in that background, right by that window behind the son's head, there looks like what might be a flat screen TV there.
Ah, okay, good point. Yes, so this probably is a recent picture rather than from 40 years ago when Tesla or when Elon would not have had any flat screen behind him.
Yes. But great picture and very humorous.
So one of the first news items that we have is we've got a graph, and if we can throw that graph up, it visually illustrates the battery decline in a Tesla Model S and X. And of course, there's a lot of discussion about this now because the concerns are that there's rapid decline, that the batteries are failing left and right. And this is a report that that indicates that the curve is actually leveling, and that a majority of cars, of course, are still functioning quite well out there.
Yes.
You had mentioned that this curve reminded you of our critical power batteries that we had charted.
Right. At Gruber Power Services, we sell sealed lead-acid batteries to go in stationary power applications, basically UPSs. And when I saw this curve, I immediately thought, wow, that looks like the battery curve, the battery degradation curve that we see in our VRLA batteries.
Mm-hmm.
And because this is virtually identical. When you put your lead acid batteries into the stationary power application, they sit on a float charge, so they typically will go down to 80% and then back up, or oftentimes will sit in between that 90 and 100% rate. And the same type of thing happens. There's a fairly quick dip early on in the battery's life cycle, and then that dip slows significantly and very slowly degrades over time. On a well-made battery, the VRLA batteries will last about 5 to 6 years before they get to a 70% or below state of charge, which then is considered time for replacement of those batteries.
If we have another image, if
Wait, what graph image are you referring to? Can you tell me the name of the image?
it is not out there, it looks like. I apologize. We will.
Can you check the images folder?
Oh, it is in the images folder, Jesse. Yes, I've got 2 folders out there. Yeah, let's throw it up.
What is the image called? I don't see.
There's only one in the images. There's images and images, and it's a single one. Yeah. And while he's doing that, we'll take a question from Lightning Rod. I have a question for today's session in relation to an upgrade path relating to existing automotive garages. Is there one particular type or brand of code reader that stands out from the rest that will be suitable for 21st century vehicles?
That's a great question.
It is. It sounds like a video too, doesn't it?
Yeah.
You know, not that we're aware of Lightning Rod, but yeah, you've piqued our interest. We'll do some research, and the graph that just got popped up shows the degradation decline on the S and X batteries. And of course, with a lot of cars running successfully out there, with some of the anomalies thrown in there.
You know, one of the things I've said in the past, and I do believe it still applies for these batteries, is that on an automobile, battery strength is more a function of mileage than it is. I'm sorry, I get this backwards all the time.
Right.
It's more a function of time than it is of mileage.
Right.
We get this from the I get this from the VRLA batteries that we sell with Gruber Power Services. The chemistry is different, but the behavior is very similar. So I'm not at all surprised to see the batteries grouped very much in that reverse hockey stick, because it's going to be time related, I think, more than mileage related as far as this goes.
Mm-hmm. And I have one other image, if we can pop up, Jesse. It is called the brick decline, and or brick delta. What we had was, and I'll preface this this picture. We had a customer in Florida about 3 weeks ago that called me and concerned because she normally charges her Roadster to 170 miles range, and suddenly it's dropping. Every charge she did, the range would drop about 12 to 13 miles.
That's incredible.
Fast. Yeah, it's usually not that quick. The lesson here is, if your car, a Roadster, is beginning a decline every time you charge, what that's indicating is you have a resistive cell, and the battery management system in the Roadster is saying, there's a problem in a brick. I'm not going to allow a charge to anything greater than that lowest brick because of safety issues. You overcharge a resistive lithium ion cell, and the result is typically a thermal event.
Right.
So this one was losing 12 to 13 miles. Sometimes customers with Roadsters say, well, let me take it to the Tesla service center, and I'll have them look at it, and we'll dig into it. And time is not on their side. The instant that it gets to zero, and it will with a resistive cell, you now have bricked the Roadster. And if any of those bricks spend any time below 2 volts, you start getting a destructive process taking place in the 68 other cells that are connected in parallel in that brick. So in other words, that resistive cell is draining the other 68.
Right.
Here you can see an example. When this car left Florida, we finally got the transporter, and we were rushing as much as we could. The car was down to 30 miles range. She was still able to drive it onto the transporter, which helps because by the time a Roadster gets bricked, the wheels get locked, and now you have to use dollies and winches, and it gets really cumbersome and expensive, more expensive to transport.
Right.
We knew that the car was going to arrive in Phoenix 5 days later, bricked, because it was losing range so quickly. And sure enough, 5 days later, it showed up, and it was deader than a doornail. It was bricked. So we immediately took some diagnostics, and here in this chart, you can see the minimum and the maximum brick voltages. The rest of the bricks, there are 99 of them in a Roadster battery pack, were sitting at 3.98 volts, or very close to that range. But one of them was down below 1 volt, 0.732 volts. And if you look at those blue lines there are 11 sheets. Each of them have 9 bricks. So you'll see 9 blue lines, then the next sheet, the next sheet. This was sheet number 3, brick number 9 that was having the problem. And you can see there is no blue line there. In fact, it's negative. It's actually showing below 2 volts. And 2 volts is the magic cutoff for an 18650 lithium ion cell. If you keep it above 2 volts, that cell will last, like in Roadsters now, 15 years.
Right.
If you get below 2 volts, it begins a destructive, there's a chemical process that takes place. Now, fortunately, this excursion below 2 volts was brief enough where we were able to immediately put it on life support, bring that brick voltage up a bit above 2 volts, and then have it on life support until it went on a lift for surgery, which means we have to pull the battery pack, open it up, pull out that sheet, and then we use special equipment to find that one resistive cell. Now here's the really crazy part. There's 6,831 cells in a Tesla Roadster.
Right.
Only one of those can cause this problem. And as soon as we isolated that cell and we neutralized it, we put a meter on it, and you could see the voltage just drop like a rock.
Well, and obviously the software takes and solves 99% of your problem. You have 99 bricks. It found the one where there was a problem. And so we went from 6,800 plus cells all the way down to just 69 cells that we were going to have to try to investigate.
And if this customer had spent any time trying to, take it to a service center, the service centers, at Tesla are not equipped to open up the battery packs. That's the same problem that we have with Model S's and X's, is they don't repair them at the service center level.
Right.
We would have lost valuable time. This brick would have been below 2 volts for some extended period of time, and now you run the risk of needing to change a sheet, the entire sheet, because you can't just change one of 99 bricks.
Correct, because once those bricks go, they're gone, and once that one brick goes, it's going to start sucking power from the other bricks in that sheet first, and then from the other sheets in the battery. Correct?
Actually, no. The bricks will remain independent of each other
Okay,
because they're connected in series in the sheet.
Okay.
So one other thing that the Roadster owners are aware of and oftentimes recommend, along with the service center, is let's pull the service plug on the battery pack to give us to put the pack into a coma.
Right.
Which works only if you don't have a resistive cell. With a resistive cell, it's going to drain that brick whether that service plug is pulled or not. And what that does is the service plug removes any loads, external loads, from that Roadster battery pack, which makes perfect sense if you have a charging problem, for example. The power electronics module in the Roadster can't charge the pack. Or there's some of the electronics are compromised. So at that point, you definitely want to pull a service plug because you want to stop the pumps from running, the VMS from operating, the 12-volt systems from being live, all of that. And then that pack will literally go into a coma and sit there until you fix whatever problem is preventing it from being charged.
Right. Okay. And like on a Model S, there are contactors that automatically disconnect every time you turn off the car. Effectively, it's like pulling the service plug every time the Model S gets turned off.
Yes, the service plug on a Roadster is the equivalent of a manual contactor in the later model Tesla cars, so it happens automatically.
Okay.
In this Tesla Roadster, in order to remove all loads from the battery to put it in a coma, you have to reach in some really inaccessible place in the back, and you have to have skinny arms in order to do it.
Yeah, I've seen those service plugs. There is no way I'm getting my
You're
arm
gonna do
in
it.
there.
I used to have my skinny teenager do it, and one of our customers actually built a tool. It was kind of like a coat hanger, thick type hook combination, and we probably should build those for the
We
customers. that
probably
need to
should
pull-
build something like that. Yes.
But anyway, we're kind of going full circle here. So this particular Roadster story was posted on the Facebook BMSU 029 site as an example of what happens when a cell goes resistive in a pack. And unlike the Roadster, where we were able to get that Roadster in quickly, get it up on a lift, pull a battery pack, the same could be done with the Model S. But again, the resistive cells are aberrations. They are anomalies. They are not normal failures. People oftentimes attribute that to, well, does that mean that the battery pack is going end of life? We don't know yet how the multi-cell battery packs like the Model S, X, of the Roadster are going to go end of life, except for that 2016 pack.
Right.
Where we had cells that were actually defective in some way and only lasted 7 or 8 years. And the end-of-life symptom that we saw there, which Mark was heavily involved in because it was his engineering team that actually led this discovery process, was there was an impedance change in the cells. In other words, they didn't have as much energy anymore. They couldn't, one customer couldn't even drive the Roadster to his house in the Malibu Hills anymore. It wouldn't go up the hills.
Right. And I remember the key to finding this actually was going back to our roots with Gruber Power Services when we had the same type of issue happen clear back in 2014 and 2015, where there was a manufacturing issue with a series of batteries that were provided to us over the course of about 6 months or 7 months, I think. They went out to customer sites, and these lead acid batteries were starting to show impedance issues. Their conductance was falling, which means their impedance or resistance as a battery string was going up. They would charge and look like they were charged properly. And that's what's happening with the Roadsters. It looks like it charges properly. It looks like it charges to full mileage. But then when a load is put on the battery, that impedance issue kicks in, the voltage drops, the car goes into kind of an emergency safety mode saying, I'm going to have to limit the power here because there's not enough power to give me. And then that's what you have on a UPS. The UPS simply shuts off.
Mm-hmm.
It's supposed to run for 10 minutes or supposed to run for a half hour, and it runs for 30 seconds or it runs for a minute. On these cars, you mash down the accelerator to get up to traffic speed and nothing happens. The car just limps along. And like you said, that one gentleman in Malibu couldn't even get up the hill to his house.
Right. So we posted these pictures of the Roadster in Florida. And if you're interested, it's on Facebook, actually. Under our site as well. And you can see the whole chronology of events that occurred as this Roadster began to die.
Getting some kind of feedback, Pete. Can you move your cord?
Oh, there we go. Okay. It was probably too close to my power cord. Isn't that something?
Yeah.
You put the mic cord next to the power cord and we start getting some feedback. Oops, there it goes again.
Yeah, we have for some reason, there's a power cord down on the floor and the mic cord is getting close to it. So thank you, Jesse. In the meantime, YouTube, Thomas Curtis says, Kia ora from Aotearoa. That's the name of the town.
Yeah, New Zealand.
And so then we have Dexter Hodge from YouTube. Question, can you comment on the potential ways that an 8 of 2013 manufacture date Tesla Model S85 could have a drive unit grinding noise that was terrible sounding, like a total replacement would be completely needed, and have it heal itself? He follows up and says, healing of the noise likely happened when out of balance rims were removed from the rear drive unit and replaced with new rims.
That one's got me stymied. It was a noise that was there that went away.
Yeah.
Yeah, I don't know.
Dexter, this is one that we will get back to you on, and we will find out exactly what's going on with that. On Instagram, I am that ICTR Mentions that Elon better employ you guys, bro.
Okay.
Yeah, thank you. Thomas Curtis on YouTube also follows up. He says, do you think LFPM, lithium iron phosphate manganese batteries are the future?
No.
I don't either. We've seen too many other battery technologies out there. Lithium, from sodium ion, potassium ion, a mixture of 4 or 5 different types of battery salts, even non-lithium batteries like solid-state batteries. And then on top of that, cars that are running on not only battery but on solar, where the battery is a very small part or a much smaller part of the overall.
Mm-hmm. The analogy that comes to mind for me is these were the girlfriends you had before you met your wife.
Yeah,
the technology continues to evolve. It continues to improve. And, who knows where we're going to end up? I know that Jesse usually chimes in at this point and says, well, fusion technology is the future. As we have said many times, carrying 1,200 pounds of DC storage around with you in a car is probably not the most futuristic, efficient way to do this. There's going to be much better technology.
This reminds me of one of the articles that I saw this last week that a Toyota had driven over 1,200 miles between fuel, on a fuel tank, and it looked like it was a hybrid. I didn't read the article really closely. It had been on one of those electric roads where the battery could constantly charge while it was driving. And so a very small battery, 30, 35 miles of range, and this car had over 1,200 miles and still wasn't needing fuel yet.
Mm-hmm. Mm-hmm.
And so that's where I think, Thomas, that the future is going. Just like we used to have old nickel cadmium that went to nickel metal hydride, that went to eventually went to what we now know as lithium ion. The battery technology is changing rapidly. And to your point about the girlfriends before your wife, we're not there yet. I think there's still a lot of change to come.
We're still dating with batteries, yeah.
One other thing too, guys, I don't know if you guys saw this, but on Twitter it was going semi-viral yesterday. An Air Force, like high up Air Force person came out as a whistleblower talking about we have non-human origin spacecraft. So maybe that might be replacing fusion even.
Interesting. Okay.
Yeah, we'll have to report more on that. It was kind of a crazy thing that was breaking yesterday.
Is this one of those things where the aliens landed in 1940 and the government kept it from us, and now the conspiracy, and now the documents are being revealed because they're no longer classified? I'm still mad about that balloon that they shot down. Of course, it could have been helium, but they might have had anti-gravity. Do you remember that unknown object that they shot down? Yeah.
Yes.
I went on a rant about that, but yeah. Well, it looks like TikTok. Jesse, you're getting a compliment. A political dissident from TikTok says Jesse is the real MVP.
Well, this podcast doesn't go if Jesse's not here. So right. I have to agree with that one.
It looks like Niles joined us from Denmark, the Bion Danish Genome Institute. He says, good morning.
And good afternoon, Niles.
Yes.
Fern212 on Instagram. How often do those packs you guys repair get isolation alerts when you put them back in?
I suppose that could happen. Isolation alerts would indicate that there is some form of conductive material, water ingress. It does happen occasionally. In the Roadster world, it's much more rare. The packs are sealed, and we've had customers, though, that, leave their cars outside. And, again, I say this all the time. Tesla Roadsters are not 100% waterproof. And if you've got heavy rains and the car's sitting outside and the water begins to pool on top of the 1,000-pound battery in the trunk, which it can because you've got a lot of gaps there.
Right.
In most cases, there's an aluminum L bracket that is fairly well sealed with urethane caulk, but not always. And if the water gets in there, then you have an immersion sensor strip at the bottom of the pack that then begins to throw isolation errors. The other one that we see also is the charge port door. In fact, one of our Tucson customers just emailed us this morning. He says, what gives? When I'm charging my Roadster now, I'm getting a red pulsing, which the color red in the Roadster charge port means there's a problem.
Okay.
The fact that it was pulsing immediately told us, well, that particular color, amber, is a combination of two colors. It's actually green and red. It looks like your green LEDs have conked out, or the string, which is typically an indication that water's gotten into that charge port door. And that's one of the areas on a Roadster that is not completely waterproof. If you leave it outside and it rains, water can migrate down into a circuit board and pool in a connector housing and then create all kinds of havoc. It begins to corrode because you have voltages there.
Sure.
You get water and voltage, and you get what's called electrolysis.
Yep.
And you start moving metal around. The copper gets deposited on something else, and you get a lot of copper oxide, which is also somewhat conductive, right?
Yep.
But
Well, and we've seen some of the same thing with Model S's. We'll have Model S's that come in and the batteries were, for whatever reason, not particularly well sealed. And we get water ingress on the batteries there, and we start to see Model S's have come in for us for repair, and they have isolation errors. We open up the battery pack and find that there's rust in the bottom of the battery pack because of water ingress into the pack. And this is not not flooded out Teslas either.
and sometimes the early designs didn't contribute to helping that problem. For a while, Tesla was dumping the condensate that comes off the AC compressor or the condenser, the cooling portion,
Right.
on top of the battery pack. And, of course, with time, that would eventually corrode. You've got a steel lid and you've got steel bolts. And if it was aluminum or stainless steel, you probably wouldn't have had the same effect.
Correct. Good
All
point.
of those problems, though, were recognized by Tesla fairly early on and resolved in most cases, but we still occasionally do a retrofit where we have to reroute that condensate line over to the side so it doesn't dump water on top of the pack.
Yeah, makes sense. Brooklyn Staten on TikTok asks us to please talk about the sunglasses.
The sunglasses, okay. It is at some point going to be a video. We are not revealing why we wear them yet. It's a well-kept secret, and it is definitely a talking point with everything that we do. And I don't know if you've noticed, but when we have guests, our guests even wear sunglasses. And anyway, my computer keeps going out on me. Sorry, guys. So at some point in time, we will have a big reveal video that explains sunglasses. In the meantime, put on your own, enjoy the show, and maybe you'll see what we're seeing.
Yeah, you need to see the filtered light.
Trucker Alistair is back. YouTube, he says, sorry, guys, for not being able to join you last week. He was on vacation visiting a friend from the Cayman Islands. But a great show as usual. Greetings today from Ohio. Speaking of Cayman Islands,
Yes.
we've got the Tesla Roadster matchmaking site, which is on our website. That's where we offer free dating service for sellers and buyers of Tesla Roadsters. We unite them, you guys get together, you discuss price, and then we come in after the fact and help you process the sale. In fact, I was going to ask you about that. I saw another title question come through this morning, and maybe you can explain to the audience how much work we do with this Roadster matchmaking site.
Oh, by all means. We, along with the matchmaking site, we are offering a free escrow service, basically, to help put these buyers and sellers together. The seller will send us the title. The buyer will send us the funds. We'll then take and get those funds over to the seller and the title over to the buyer once they both agree that everything looks good with the sale. That can take us a fairly significant amount of time. We also have, we get all kinds of questions about that. For example, one buyer came to us this last week and said, or one seller came to us this last week and said, I want to sell my car to somebody in New Jersey, and he doesn't want to pay sales tax. But the way that it's looking like it's going to happen, we are going to be stuck with this. And on a sale of over $100,000, it's going to be a lot of money. So can you help us? And I was able to help figure out a way for them to conduct the transaction to avoid paying sales tax, but do so legally.
Okay, well, that was important. I'm glad you added that, and do so legally.
Oh, absolutely.
Okay.
Absolutely.
So the reason I mentioned this, when I saw Cayman Islands, we have a car out there now which deviates from Roadsters. This is a Lotus that is being sold by a customer that lives in the Cayman Islands. The car is currently in the UK. And the more this story unfolded, the more intrigued we became. Initially, our reaction was, no, we only do Roadsters.
Right.
We're not going to sell your Model X, S, or that Ford Fusion. It turns out that this is an interesting story in that it was a one-of car. It was built by many of the same design engineers and the engineers at Lotus after the Tesla Roadster project. So there was a lot of Roadster DNA in this car. And it was the byproduct of the UK government, after watching Tesla with their Roadster, decide that they want to get in on this. And they began offering grant money to a number of car manufacturers in the UK, and Lotus was one of them.
Right, right.
So far, it looks like indications are that anywhere from 17 to 23 million dollar, I'm sorry, 17 to 23 million pounds
Right.
went to Lotus to build this car, which, if you think about it, is an enormous amount of money. But for a first, prototype version, maybe not. So they built this car. It looks like a cross between a Tesla Roadster and an Evora. It is a hybrid, so it is truly part EV and part ICE engine. And the ICE engine is very small, and its function in life is to charge the battery when it gets low.
Right.
So it doesn't look like it's part of the propulsion system, other than to provide a charge. So this is reminiscent of the T0 towing a Honda generator behind it, operating on batteries. But anyway, when you mentioned Cayman Islands, I had to tell you guys about this car. If you're interested in looking at this unusual car, it is on the Tesla Roadster matchmaking site on our website, and it's being offered for just north of $1 million. And it is one of it. Nothing like this will ever be built again. And if you're a collector, this might be the car for you. We even did a video with this. So if you're interested, go to the listing. And inside the listing, you can see a video that describes this unique one-of car.
One other comment for Trucker Alistair as well. At some point, Trucker, we've seen you anywhere from Nova Scotia to Alabama. I certainly hope that you can make your way to Arizona at some point, and if so, you look us up.
Definitely.
We would look forward to meeting you.
And we'll give you a tour.
And so now, I think we've already mentioned that Niles had said good morning on YouTube from the Bion-Danish Genome Institute. Lightning Rod on YouTube also says that sound online for YouTube is 5x5. Not exactly sure what that one means, Jesse.
I think he's saying 5 out of 5. I hope it means it's good. I don't know. Let us know, Lightning Rod.
Yeah,
Okay.
let us
All
know.
right.
5 out of 5 would be great.
I'm up on my microphone, Jesse.
Well, no, he was talking about the issue you had with your power cord interfering with the audio.
Oh, okay.
Yeah. And now we've got Pete's PC turning itself off every 3 or 4 minutes because
Well, it's just the laptop
It's going to
into
sleep.
Yeah, it's just turning off the screen to preserve battery. You can just move the trackpad; it'll come back on.
yeah,
Did
so
you unplug my laptop or my
it's
power
it's
supply?
currently
Your
unplugged.
power cord was
Oh.
tangled in with your mic cord. I had to get rid of it.
Okay. All
So,
right.
Lightning Rod. I've been paying attention to batteries for decades, 5 of them, and until recently, there's been very little improvement. In the last decade, the rate of change is astronomical. I'm sure in the future we will have batteries with the power of the suns. So I think that's a response to Thomas's question about whether or not the LFPM battery is the future. And Lightning Rod, we both agree with you on that one, I think.
Mm-hmm. Mm-hmm. Looks like. Oh, I missed that one. Okay. What's the biggest capacitor explosion we've ever seen? It's from Political Dissident on TikTok. Backstory, please. If we're referring to that battery fire that occurred in that Model S,
Yeah.
those are 18650 cells.
Yes.
Multi-cell. So it wasn't a supercap type battery.
Yeah, I'm not. Have we seen any actual capacitor explosions on either a Roadster or a Model S to date?
Not to date. The last one was in Germany. It was inside a power electronics module, and the customer is very lucky because when a capacitor blows its top, it's full of metallic fragments.
Yes.
There's a foil inside, and this had literally conductive foil all throughout the boards, and somehow nothing shorted, nothing. So just changing the cap and then rebuilding the PEM was all it
Wow.
required.
That was amazing.
Yeah. We're actually doing our critical power podcast Friday mornings now, and one of the things that we videotaped this morning was a capacitor replacement on an inverter power board, and it was reminiscent of what we do with the Tesla Roadsters.
By all means, we've seen a few the results of a few of those capacitors explode in some of these large UPSs, and it is ugly. And in fact, there have been cases where the entire UPS has just been completely toasted and had to be replaced.
There was actually a building in Texas over a decade ago that had a bank of capacitors blow up because they were aged, resistive, and they were overheating, But this building actually caught on fire and burned to the ground. There were some ugly lawsuits for a period of time after that.
Wow, that's something else.
So I have something that inspired me that I found on YouTube, and it's a simple sentence. It says, "The future belongs to those who believe in the power of their dreams and have the courage to chase them beyond the boundaries of today's reality."
I love that saying. It's a visionary statement they have, and this is from our favorite one of our favorite AI programs, Midjourney. We use Pete, you use Midjourney to make our backgrounds now, and there are these wonderful futuristic automobiles and houses and buildingscapes. It made me think about, okay, there are few visionary things that we have seen in our lifetime. For example, around the turn of the century, Bill Gates was widely mocked for saying computers are going to eventually be more than just glorified calculators. They're going to, in fact, he said, in 10 to 15 years, the primary function of a computer is going to go from being a computation device to being a communications device. He was absolutely visionary in that, and that's exactly what happened. Similar to that, if you remember, Steve Jobs came out in 2007 with this weird-looking phone that had no buttons. And the iPhone and smartphones as we know it have never been the same. Or even a year later, Elon Musk and team put together a car that people really joked about. And I know you're going to get into that in just a little bit, that they didn't take Tesla seriously. And it was all because Elon Musk and Tesla and the team there believed that an electric car could be both functional and cool. And something more than just a novelty or a golf cart or something like that.
My old boss, CEO of Digital Equipment Corporation, the world's second largest computer mainframe manufacturer at one point in history, now basically gone. But anyway, Ken Olsen was famously quoted at one point in time saying, "Why would anybody want a computer in their house?" So being a successful CEO and entrepreneur doesn't necessarily mean that we have great vision and can see the future. But these two guys that you mentioned definitely were able to see the future.
Most definitely.
So we have another picture there. If we can throw that up, it is the caption on this is, "If Tesla existed in the 1980s." And this is a shop that does EV conversions. And what they ended up doing was, and there are a couple of images here, Jesse. We've got Fiero-1 and Fiero-2. They took a 1980s Fiero. Do you remember those little Pontiac sports cars?
Oh, yes.
They were rear engine and two-seaters, and usually red. In fact, one of our first receptionists used to drive a red Fiero just like this, Erica. But they took one of these and they converted it to an EV using Tesla Model S parts. And you can see some of the Tesla modules in the front portion there. And according to this article, they were able to squeeze 16 of them into this car, which is quite a feat if you think about it, because not only do you have a space constraint, but you also have a lot of weight. There's 1,200 pounds in 16 of these modules. That's what an 85, P85
Yeah,
Tesla Model S
yeah.
weighs. Tesla charger, Tesla high voltage junction box, DC to DC converter. How they squeezed all this in here is a miracle, but my hat's off to them. And you can see there's another picture here. If we can go to number 2, you can see it from the back.
Well, I know that the Fiero was made from 1984 through 1988, so this is one of the later model Fieros that was made, and this was a small rear-engine two-seater car. So, I had a good friend in college actually who got one of the 88s when he was just getting close to graduation. You know how we go out, you're going to graduate, get a new car, and accumulate a bunch of debt, and because you
Yeah,
have
that part.
you make money now. But the Fiero, so it had virtually nothing in the large trunk. In the trunk area in the back was very small. That's where the engine sat. In the front area, what would we call a frunk now, though the term didn't exist then, but that was largely open. And so if you were to take out the transmission, take out the engine, you have that frunk area. I could see where they'd have potential for space for that. The thing about this car, though, it was only about a 2,400 pound car. It was a
Right.
very lightweight car. So driving this would be a lot of fun. Stopping this, not so much, because it would have shock issues, it would have brake issues. So I'm sure that these guys have gone through and done a lot of upgrades for it.
They must have done some suspension upgrades for sure. Yeah. Fascinating.
Very fascinating.
So, July 1st apparently is the 20-year anniversary of Tesla. And it's hard to imagine that they've been around that long because we typically, most of us became familiar with Tesla around 2008, 2010, 2012, somewhere in there. But the early days of Tesla go something like this. In 1997, Martin Eberhard and Mark Tarpenning were operating the e-books business or e-reader company. And while developing this rocket book, they called it, Rocket eBook, they saw that lithium-ion batteries were making great strides, and each iteration of these fancy new batteries made the e-reader lighter and allowed it to run longer. Now, what an e-reader is, it's fundamentally the predecessor to the iPad.
Yeah.
It was an electronic book with a screen, not a high-quality screen initially, and, of course, electronics and batteries, which made it weigh about a pound. It's kind of heavy
About
for a
that,
book.
You know, the Barnes & Noble put out their Nook. Rocket was a big one.
Right.
Some of these e-readers were even had a paperwhite display, so they didn't even have their own LED in the background.
What I found interesting about this part of the story about the batteries is that later on, when Martin had sold this e-reader e-books business, he was a sports car guy and he wanted to get into a sports car apparently, and he didn't want to go with an internal combustion engine version because the EV1 had just made its big splash, and
Right.
you know, in California there were a lot of people upset about. Yeah, there we go. We got the e-reader.
That's a rocket book.
Right. And you can almost see where the lithium-ion batteries would fit along the side there, stacked on top of each other.
Yep.
So he was looking to develop an electric sports car, went to see AC Propulsion Systems, looked at the T0, saw that it was a lead-acid-based EV with about 80 miles range, 28 12-volt Optimus spiral wound batteries buried in the frame, which is part of what we have up on our tribute wall in the shop, by the way, is a T0 with a recreation of where the batteries were placed in the car, so you can see a cutaway view. And he convinced AC Propulsion to replace those lead-acid batteries with multi-cell lithium-ion battery packs, which now took the range from 800 to almost 400 miles, and the 0 to 60 from 4 seconds down to 3.7 or 3.8 seconds, somewhere in that range.
So from 80 to 400 miles, and 20% faster 0 to 60 times.
Mhm.
Wow, that's something else.
So they took this T0 to Laguna Seca, and there were a lot of people took notice, especially the Lamborghinis, Ferraris, and McLarens, because this little electric sports car was actually beating their 0 to 60 times.
Sure, because at that time, 4 seconds 0 to 60 was incredibly fast.
Mm-hmm. Very much so. So at some point in time, Elon apparently also heard about this T0, and we've told this story many times, but he went to AC Propulsion and said, well, are you going to build this car? And they said, no, we're an engineering firm, basically, and we're not a car manufacturer. So Elon said, well, I'd be interested in building this car, building this electric sports car, mass producing it, in other words. And they told him that a couple of guys are already doing it. And that's how Elon got acquainted with Mark Tarpenning and Martin Eberhard and joined the company as a first-round investor, gave them $6.5 million, and the rest is history. It took off from there. By the way, you might be wondering, what happened to the e-reader, e-books business that Martin and Mark started? They were actually talking to Jeff Bezos for a while to put this thing on Amazon, or Jeff was going to become an investor.
Okay.
And Barnes & Noble at the same time, and it was back and forth between the two of those as to which one would end up with this, and it eventually went to Barnes & Noble, as it turns out.
And it ended up becoming the Nook then, because that is Barnes & Noble's technology. I loved also when I read through this excellent article that you had found. They decided to name the company Tesla after Nikola Tesla from the early 1900s because he was the pioneer of the three-phase AC induction motor.
Yes. Yep, very much so. Compared to Thomas Alva Edison, who was a DC proponent, and it was actually Westinghouse and Tesla that were promoting now AC.
Right.
And the fundamental reason that DC lost and AC won was because with AC you can use transformers and you can step it up and down. So if you're generating power at Niagara Falls, a hydroelectric, and you want to bring that across New York State, you simply step the voltage up to hundreds of thousands of volts, and you get much less line loss than if you were trying to, bring the native voltage coming out of the generators or the alternators all the way to New York. You'd have so much power loss.
Right. It was all about that line loss and ability to step the amperage down to virtually nothing.
Mm-hmm. And then, of course, the other side of it is a three-phase AC induction motor is infinitely more efficient than a DC motor because there are three phases, 120 degrees out of phase, that are pulling the magnetic field into the rotation. Mm-hmm. And you get regenerative braking to boot.
Yes. By the way, for those that might be hearing a kind of a nail gun type of sound in the background, because I hear it every so often, it's a nail gun.
Those are pallets being built. We are shipping product every day. To me, it's the sound of money.
Absolutely.
So I enjoy it.
One other thing, guys?
Yes.
Before we get off of Nikola Tesla, one of the reasons I think also that they went after that is Elon's a big proponent of being open with your patents and technology. And that's one of the things that Tesla really believed in back then, as opposed to Edison, who was
a patent troll.
Yeah.
Exactly.
Yes, he was.
That's also known about Elon when he founded OpenAI, or was one of the founders of OpenAI with Sam Altman. They called it OpenAI because it's going to be completely open source. So that's one of his things that he lives by.
Fundamental cultural, or part of their culture.
Yeah, great point, Jesse. Definitely great point.
There's one more image I want to pop up, Jesse, and it's the Tesla doubters image. And these, they first announced the Roadster, by the way, in 2006. And they were moving forward with the production. And these are some of the headlines that came out. And you can see that this is a lack of vision, total lack of vision. But, of course, without EVs everywhere, these were legitimate positions at the time. Except for the part where they say Tesla has failed massively as a public company. Well, yeah, they were on the verge of bankruptcy often, but there was a lot of commitment to the cause from the early days.
Speaking about our visionaries from earlier, this is exactly what I was talking about. It's the people here were looking at what was, not what could be.
Right, right. So I've got another interesting tidbit here for you, staying with the history of Tesla here for a moment, and we'll probably discuss this in the next few podcasts because it is a momentous occasion,
Oh, by all means.
and a big milestone. But in 2010, June 29th, Tesla became a public company via an IPO, initial public offering, on the NASDAQ with the ticker symbol that they're still using, TSLA. It was the first American car company to IPO since Ford Motor Company had gone to market more than 5 decades prior in 1956. So quite notable. The original IPO share price was $17 a share. Now, let's go forward a bit and let's go to today. That $17 per share today is worth $2,900 per share. And the number of splits that they have gone through, you would be up, let's see if I've got this, 15 times more shares than you purchased. So every share you purchase would be 15 today.
Right. There were 2 splits. One was a 5-for-1 split, so every share turned into 5 shares. And then later on, and just a couple of years ago, there was a 3-for-1 split. So those 5 shares, each one of those 5 shares would be 3 more shares, making 15 shares.
Mm-hmm. Exactly. So I am a Tesla investor, by the way, have been since 2013 when I first got my Tesla Roadster. And I would be filthy rich today, but I fancy myself as a day trader, and I always got on the wrong side of that equation. So today I'm just leaving it alone. I haven't touched it in like a year and a half. And the other thing that scares me is capital gains. You take a bath when you finally cash out. So, but in the meantime, I'm looking at it as a long-term investment. And like we've said many times, to me, it's a good strategy because you look at all of the production capacity that is under construction now and an seemingly unlimited demand for their product. So it, in my opinion, has nowhere to go but up.
We've made, you and I have talked about this in the past as well. The electric vehicle market is still in its very, very early stages, in all truthfulness. Electric vehicles back in the early 1900s lost out to the combustion engine. There was reliability issues, there were range issues, there was infrastructure issues, and it just in the 1910s and 1920s, those issues just were unsolvable at the time compared to the combustion engine. Today, what have there been? 20 or 25 brands either put out or announced or models of vehicles in just the last 2 years. And I think that pace of adoption is going to go out over the next 3 or 4 years. Most of the European car companies, with a few notable exceptions, thinking of Ferrari or Lamborghini, have announced that they're going to be EV only within the next probably 10 to 15 years. Volvo is 2030, for example. Even Ford Motor Company is saying that they want to be 100% electric vehicles by 2035.
Mm-hmm.
And so these are major, major automakers out there. That also means that the market for vehicles overall, which right now is about 92 or 93% ICE and about 7 or 8% EV, is going to flip on its head over the next 10 years.
Mm-hmm.
And think about that, guys. If Tesla is the market leader right now at 1.5 million vehicles a year, even if when it gets to a 50-50 split, Tesla will be the market leader at about 15 million vehicles a year.
Mm-hmm.
And when it truly flips, where there's 90% EV and 10% ICE vehicles, Tesla would have to be making well over 20 million cars a year in order to be that market leader, which in fact happens to be the amount that Elon says they're going to be making by 2030.
Yeah. Very true. Very true. Well, it looks like Lightning Rod has a conclusion here. He says you have to wear glasses, and he's talking about the sunglasses. Again, we get that occasion often, to see the secret channel, we call it, Gruber vision. Now, we do have a green screen. What he's suggesting is there may be another green screen or some other portal that only certain sunglasses will give you. So we'll have to wait to see how that pans out. And we are going to be selling sunglasses soon. We have the sunglass cases already, and we're still shopping for the right
we do.
set of sunglasses. So keep watching our website for some swag because it is coming, and we'll be able to show you what we're seeing behind the sunglasses as well.
By all means. Niles from Bion Danish Genome Institute tells us or asks us, would it be an idea to create a Gruber emergency guide that Tesla owners get easy access to in the style of if this, then do that, including shipping the car to you? Niles, that not only is a great idea, when you look at our website, I know that we are mostly Roadster focused. We're going to become more Model S focused as more Model S's come off of warranty. But we have a Roadster tips section of that site that's very similar to what you're asking for.
Brilliant idea, Niles. You're always great with new ideas, by the way. Yeah, that
By
would
all
make
means.
perfect sense. One of the things I was going to do today, actually, was we share tips with the Tesla service centers, and one of them is going to be to remind them, here's the difference between a pack that you can pull a service plug and preserve by putting in a coma, and here are the symptoms of a pack that you're not going to be able to do that with, and it will brick even if you pull the service plug.
Yeah, taking the time to compile that all into one document or one basically how-to or FAQ is a great idea. So thank you for that idea.
So YouTube Lightning Rod says, and he's talking about that Lotus 414E, by the way, was the name of that prototype vehicle that is now for sale on our Tesla Roadster matchmaking site. He says 23 million pounds might sound like a lot for a one-off Lotus until you see the options loadout. 23 million pounds, did the math, that's $20.5 million for a single car. Of course, you throw in engineering time and all of the details that you have to hammer out, and the trial and error and the things that don't work out. It's kind of like, Tesla with the dies for the first Model S's, getting steel stamping dies versus aluminum.
Yeah,
and then having to repurchase them.
Yeah, then having to repurchase them, and just the purchase of these dies could have been a couple $1 million in order to get them completely done and put together. Last week we had something that had come up, and I don't recall if we got very closely to it. There was a question asked about the 4680 cells and whether or not the 4680 delays were going to significantly delay Tesla and the Cybertruck and the Model Y and all that stuff, because Panasonic had announced that they were going to be delaying their 4680 cell production all the way until the early part of 2024. Originally, they were going to be doing cell production starting around now, second quarter of 23. The short answer to that question, of course, that our user had come to or had asked is no, I don't think it's going to delay it at all. And that's because while Panasonic has announced that they're delaying their production of 4680 cells, the cars that Tesla are putting out right now that have the 4680 cells, Model Y standard range, are exclusively made with Tesla's own batteries.
Oh, okay. Okay.
So the 4680 battery cell, if you want a mental picture, is almost like having a D cell alkaline battery as opposed to a double A cell alkaline battery. They're significantly heavier. They're about 3 to 4 times the weight, and yet they don't take 3 to 4 times the space because how as a circle expands, it gets exponentially heavier. Or exponentially larger. A 16-inch pizza is twice as much as a 12-inch pizza, for example. And so Tesla produces their 4680 cells in their Texas Gigafactory, and those go into their Model Y. As of right now, Tesla's demand for 4680 cells is being fulfilled completely internally.
Interesting. Okay.
And so the
That makes sense.
the 4680 is a really interesting technology, though. The 2170s or the 18650s are typically an older technology. They're less efficient than the 4680s. They do have a little bit higher chance to catch fire based on a tweak in the electrolyte for the 4680s that helps to make them not quite as reactive to fire. And the 4680s are being put in these foam packs that are almost like a structural pack. It's going to be a potential challenge to repair these packs, but not something that I think is going to be insurmountable.
You know, it's interesting you just mentioned that. While you were saying all of that, I recall that in that article about the 20-year anniversary for Tesla, that one of their successful programs is that they are heavily vertically integrated, and that came out of a need to do so because with building the Roadster 2400 vehicles, they couldn't get any of the real vendors to take them very seriously.
Right.
In fact, complaints were from some of the veterans there that some of the vendors wouldn't even call them back, you know, despite the fact they were trying to place orders, which then forced Tesla to start making some of their own products for the supply chain, circuit boards, for example, doing their own software work. And to me, that was reminiscent of our trajectory in having to reverse engineer in order to compete as an independent service organization in the power world.
Oh, absolutely.
You know, none of those manufacturers were going to support a competitor by giving them documentation, test points, schematics, you know, so that they can repair. And it sounds like Tesla has gone through the same trajectory, and that downside initially turned into a solid upside, which, by the way, we used when we started working on Teslas.
Yep.
Our ability to reverse engineer and recreate documentation and schematics is definitely part of our success with Gruber Motor Company.
Well, you know, when we saw the real severe chip shortage for vehicles that came out of the pandemic, it's still there as kind of a thing, but the chip shortage is lessening over time. One of the companies that was least impacted by the chip shortage of all places was, of course, Tesla. Why? Because they had so much of their own vertical integration. They understood exactly how to work around the problems because they've had to work around problems like this for their entire 20-year existence.
Good point.
Places like Ford and GM and other car companies just threw up their hands because to them, the chips were simply a black box, and they had no ability whatsoever to accommodate the potential change that needed to take place.
Yeah. Well, it looks like we may be wrapping here. We'd like to notify you that tomorrow, Wednesday, is our Tesla Roadster podcast. It's also at 10 a.m. Pacific Standard Time. And even though you may not have a Roadster, if you're interested in the vehicle, join us. We'll entertain questions. We usually cover topics directly related to the Roadster, which actually we did today a bit, tying in the Roadster with the Model S BMS 029 Airs. And then Thursday, again, we want to remind you that we're going to have Farzad Mesbahi with us, a very knowledgeable EV space contributor and influencer. Should be an interesting interview with him as well.
Really looking forward to talking to him.
And also, guys, just a shout out for anybody that wants to learn more about critical power. Go check us out. We just created all our social media accounts, so you can find us by searching Gruber Power Services on YouTube, TikTok, Instagram, and we'll be making the Twitter here shortly as well. So any support over there would be appreciated.
We would love to get subscribers, and you'll find that the similarities in the type of technology we work on in Gruber Power Services on critical power equipment is very closely related to what we're doing with the EVs, with the Tesla vehicles. Same basic modular components, DC plant, a little newer technology in EVs. We're using lithium ion versus lead acid, which is still prevalent in the critical power world, and then a three-phase inverter. Only difference is what it powers, but you'll see the similarities. So feel free to join us. That podcast takes place every Friday morning at 10 a.m. Pacific Standard Time.
So one last comment that we have here on Instagram from the Wild Bunch of Wolves, 4 thumbs up. So thank you very much. We appreciate your support for us. And I think with that, we're going to go ahead and bring this one to a wrap.
We appreciate you joining us as always. We'll see you tomorrow or next week.
Take care.